So this is the video lecture introducing probability distributions. We're going to shift gears a little bit now in the course away from descriptive statistics. And we're going to look at some tools now that are going to help us when we do inferential statistics. We probably won't do probability in the same way that you might have seen before in some of your other classes, because we're going to minimize it and look only at what's going to be helpful to us in the inferential statistics portion of the course. So let's start by introducing the term random variable. That's exactly what it sounds like. It's a variable that's assigned the random outcome of an experiment. So an example, X might represent the heights of people in the world. That variable could take on different values at different times. So if I pick somebody who's 5 feet 7 inches tall, then when I pick that person, then the variable X represents 5 feet 7 inches tall. But if I pick a different person, I get a different value. If it's not a random variable, it's a fixed quantity. Fixed quantity is exactly what it sounds like. So let's look at an example. Let's look at the time it takes to drive from the Charlotte airport to the Atlanta airport. That's going to be a random variable because the value, the amount of time it takes to drive from Charlotte airport to the Atlanta airport is going to vary based on a lot of different factors. So that's going to be a random variable. By contrast, let's look at the distance between the Charlotte airport and the Atlanta airport. That one is going to be a fixed quantity because that value doesn't change based on, traffic, time of day, who's driving, etc. Okay? So that's the difference between a random variable and a fixed quantity. So take a minute, if you would, pause the video and look at, see if you can decide whether each one of these is a random variable or a fixed quantity. All right, so let's go over the answers then. On the first one, the number of times the letter E appears on a randomly selected page of the newspaper is going to be a random variable. That's because if you pick a different page of the newspaper, you're going to get a different value, a different number of E's. The second one, that one's going to be a fixed quantity because that doesn't change based on the particular one that I pick. The third one, that one's also going to be a fixed quantity. That value is set by Congress. And then number 4, that's going to be a random variable because if you roll the 2 dice again, you might get a different value. Okay, so that's what those answers are. So random variables, and we focus on the numeric ones, they have 3 things. The first one is a distribution, which, just like we've seen before with distributions, is a way of showing all the possible values and how often they occur. So they're probabilities of those occurring. And then we also look for the mean and the standard deviation. I'll point out that random variables describe the population. So if we're talking about the amount of time it takes to drive from the Charlotte airport to the Atlanta airport, that random variable would represent all of the possible values in the population. Therefore, this mean and this standard deviation here are mu and sigma, not x bar and s. So mu and sigma here. So probability distributions look a lot different based on whether they're discrete or continuous. And we talked about that before, but let me just remind you again, discrete are usually restricted to be whole numbers. Continuous are not. They could go out to any number of decimal places. So we're going to look right now just very briefly at discrete random variables. So this is an example of one. With a discrete random variable, the ones we're going to look at anyway, you just see a list of possible values for x, and then a list of their associated probabilities. So in this case, we've got the number of eggs that are broken and a randomly selected half dozen of eggs. So somebody has figured out that it looks like 0 eggs are broken 35% of the time. 1 egg out of the 6 is broken 25% of the time, etc. So if we randomly select a carton of 6 eggs, the probability that none will be broken is 0.35. That's equivalent to saying that of the population of half dozen egg cartons, 35% have no eggs broken. Okay. If we were to randomly select 6 eggs, what's the probability that the carton has more than 2 eggs broken? Well, more than 2 would be 2 or 3 or 4 or 5 or 6. So we could just add all of those up and we would get 30%. Okay, so that's all we're really going to do with the discrete ones. Let me just mention one other thing here, and then we'll get started with the normal distribution. The rare event rule, sometimes you'll see that in your book, in your homework. If you're doing a probability and they ask you, is it rare? Is it rare that this would occur? The rule of thumb is that if the probability is less than 0.05, it's rare. Otherwise, not so rare. So back here, if we looked at the probability of selecting a carton of eggs that had exactly 5 eggs broken, that's 0.04, so that's going to be rare. All right, so that's it for this lesson, and you can move on to the normal distribution.